Da får vi tro vi har fått alle knappene på plass. God ettermiddag, godt folk. Mitt navn Torbjørn Digernes, president i Norges Tekniske Vitenskapsakademi, og har gleden av å ønske velkommen til denne seansen her, som en del av utdelingen av NTVAs Ærespris i 2023. Det jo et av akademiets store høydepunkter i løpet av et år, å gjøre den utdelingen. Så det spesielt hyggelig å se at det så mange folk i salen, og at vi nå får selve prisutdelingen senere i kveld på Ledål. Så fordi at tida der var begrenset, så har vi laget et seminar i forkant, slik at vi får presentert temaet som prisvinneren har jobbet i og med i sin karriere. Denne prisen, en æresprisen, den deler vi ut hvert år etter forslag fra eksterne, og vi har en jury som vurderer alle forslagene, og de lager en innstilling til NTVAs styre, som da vedtar hvem som vi tildeler prisen. Og i år det da Dr. Tao Yang fra Equinor, som har fått denne prisen, som kalles for en pris for banebrytende teknologi. Det altså den fulle titelen. En prisvinner, en eller flere, må ha utviklet på en fremragende måte ny teknologi til beste for det norske samfunn og utviklingen av norsk næringsliv. Intet mindre. Og dere vel ganske, de fleste av dere her vel godt kjent med Tao Yangs gjerning, og det han har jobbet med. Det jo det å identifisere eller analysere en brønn under boring for å identifisere reservoar, olje og gass. Så man vil altså se om en brønn vil produsere olje og gass mens den under boring. Og teknologien fører til et betydelig effektivitetsforbedring, samtidig som den gir store reduksjoner i utslipp. Jeg vil kort referere noe av juryens innstilling, som da begrunnelsen for at Tao Yang får denne prisen. Det basert på en stor reservoarfluid-database bygd på data fra norsk kontinentalsokkel gjennom 50 år, og bruk av maskinlæring har prisvinneren stått for et teknologisk gjennombrudd for å muliggjøre nøyaktig identifikasjon av olje og gass under boring, basert på rimelige og lite brukte mudgassdata. Teknologien har blitt verifisert fra mer enn 100 brønner fra Equinors globale oljefelt, inkludert norsk kontinentalsokkel, Brasil, Kanada, USA og Argentina. Og for utvikling av denne metoden har prisvinneren oppnådd vitenskapelig anerkjennelse og blitt tildelt flere internasjonale priser. Med nøyaktig identifikasjon av reservoarfluid fra mudgass har betydelig kostnadsreduksjon blitt oppnådd ved å redusere bruken av dyre nedhullsverktøy som prøvetaking under boring og nødvendig bruk av magnetresonans. Den nye teknologien kan gi olje- og gassinformasjon for samtidsbeslutninger om brønnplassering, komplettering og potensielle sidespor. Felteksempler i stor skala har vist at anvendelser av metoden gir betydelig økt verdiskaping. Teknologien utviklet av årets prisvinner har skapt stor forretningsverdi og samtidig redusert utslipp av karbon. Den videre implementeringen av fremtidige brønner på norsk kontinentalsokkel vil gi milliarder til det norske samfunn og sikre lave karbonutslipp i olje- og gassproduksjon. Det litt nedkortet begrunnelse, men den forteller med all tydelighet at denne prisen gis for en prestasjon som har hatt og vil få stor verdi for det norske samfunn. Da skal jeg få overlate ordet til Tor Inge Aag, vår generalsekretær i Akademiet, som skal lede oss gjennom ettermiddagens foredrag.
Ja, jeg kan vel bare bruke den sånn. Og vi faktisk et par minutter innenfor tidsskjemaet vårt. Så jeg vil bare gi ordet til James Elgenes fra Equinor, som manager, subsurface data og informasjonsteknologi. Det passer veldig godt til temaet. Hans presentasjon heter Digitalization as an Enabler to Compete in a Changing World. Så det oppe. The big file. Okay, this one.
Okay.
Then I think we're in business.
Very good. Thank you for the introduction, and good afternoon, everyone. My name is James Elgenes, and as mentioned, I'm a manager for subsurface data and information in Equinor. As you can hear from my accent, I'm British by background, but I've been in Norway for 12 years now, mainly practicing as a geophysicist, but in recent years, I've taken a keen interest in technology development, implementation, innovation, and more recently, digitalization. So the title of my presentation today is Equinor Digitalization Competing in a Changing World. And this picture that I have behind me represents the network of fiber optic cables on the seabed that stretch around the world. In total, there are 1 million kilometers of cable, which stretch around the world 30 times over, equivalent in length. And these cables have recently been laid down by Amazon, Google, Microsoft, and Facebook, and are one of the reasons why the disruption during COVID wasn't as great as it would have been if that had happened 5 to 10 years ago, because now we can work from home and we have efficient internet connection. So this is one of the biggest changes that we've seen in the last couple of decades. And to exemplify another change, I want to bring up the concept of unicorn companies. These are companies that are privately owned, worth over $1 billion. In 2014, there were 40, and now there are 1,209. There's a huge amount of innovation happening in the world in the past few years. And a lot of these companies are fueling the digital economy with artificial intelligence, analytics, data management, data operations, cryptocurrency, etc. And some of the early unicorn companies you probably would have heard of. Airbnb, for example, the biggest accommodation provider without actually owning any accommodation. Uber, the biggest taxi company in the world without actually owning any taxis. Spotify, the biggest music provider in the world, despite not actually owning any music. So there's a lot of changes happening. And in Norway, since 2020, we now have 3 unicorn companies. It's Cognite, who are offering industrial data operations to many companies. June Analytics, who supply analytics on top of cryptocurrency. And Gelato, who do on-demand printing of digital stuff on top of products. Just as an example of which, this was a Father's Day present to me from my wife, and an example of what this company supplies. So many of you may have watched the Likeland program, which really told the story about how Stavanger became an oil-rich city, which changed the fortunes of Norway in general. And we may be on to another Likeland, a digital Likeland. And that's because of excellent IT infrastructure in Norway. We have renewable energy powering the data centers and an increasingly tech-savvy population. But of course, for all of the success cases, we also have examples of companies that haven't quite made it in the world. Companies that have gone out of existence, like Blockbuster, Topshop, and Borders. Companies that have been bankrupted, like Chesapeake Energy, Texaco, and Chrysler. And companies that are severely disrupted, like Nokia, MySpace, and BlackBerry. And it was in part because many of these companies didn't understand how we would live and work in the future that led to their downfall. For example, Blockbuster could have bought Netflix 20 years ago for $50 million. At the time, the Blockbuster CEO thought it was a joke. You know, why should they spend that much money on this? Now the joke is very much on Blockbuster, who are out of existence while Netflix is worth over $150. So it's essential for companies like us to be aware of future trends and ways of working. No company is too big to be disrupted. So now bringing it back a little bit more to Equinor. This is a quote from our CEO, Anders Opedal, when we released our new strategy, which had an ambition towards net zero and more focus on renewables. He mentioned at the time that we need to prepare for a future that will be quite different from what we have today. So our competitors are moving forward with high speed and looking at what's going on externally. I see that if we're not preparing for the future, we will fall behind. So if the pace of change outside of a company is greater than inside a company, then again, you're at serious risk of disruption. And that's why it's important for companies to have digital strategies that will focus and make sure that we are ahead of the curve. One of the main messages I want to get across today is that digitalization is not just about technology. It's about transforming the interaction between data, people, and technology. And for us, it's to deliver on our Equinor strategy shown on the left-hand side here. Always safe, high value, and low carbon. And with digitalization, we think we can focus on four main areas where we can get a lot of potential. It's using data to improve safety, reducing development and operating costs, for example, unmanned facilities, increasing recovery and discovery through data analytics, reducing greenhouse gas emissions, and helping us with our renewable workflows. And we've already seen tangible value creation from digitalization. This is all on our Equinor.com. We've calculated back in 2020 that we've created $1 billion of cash flow improvements, and we want to deliver over $4 billion of cash flow improvements by 2025. We want to reduce CapEx by 30% and reduce drilling costs by 15%. So a lot of ambitious targets here. And one technology that is helping us now and will certainly help us in the future are fiber optic technology and data. So in essence, these are the same cables that provide internet to your home. We stick them down our wells with slight modifications, so we can turn them into microphones, and we can also monitor temperature, for example. And this is a huge amount of data that's being generated here. It's roughly the equivalent of 10,000 Netflix movies being streamed every single second. There's 500 terabytes of data every single week. And before, we would have had to put a hard drive onto a helicopter and then transport it onshore. It would have taken 2 to 3 weeks to get these data to the fingertips of our interpreters. Now we get these data in real time. We stream it directly to the cloud, and we can analyze the data in real time, which allows us to make much faster decisions. And we've shown, for example, we prevented 4 interventions in 4 separate wells on the Martin Linge field, which would have delayed the startup significantly, saving us hundreds of millions of kroner of value. We prevented shut-ins and wells in Johan Sverdrup, and we've detected leaks before we would have detected them previously. So it's also got impressive SSU implications. Another example from the real-time space here, and the reason why we're here today, and we turn dreams into reality using machine learning. We can predict the gas-oil ratio and density whilst drilling using mud gas data and machine learning. And this is something that the industry has worked for decades to accomplish. And we've now implemented this on many fields. Has led to tangible value creation. And one of the reasons why Tao is picking up awards seemingly all over the place. And we can also compare the machine learning model here to the empirical equation. So the black points there represent the machine learning model, and on the right we have the empirical equation. So the closer the points are to the line, the better the model. And we're showing that the machine learning model has potentially 60% better accuracy than the traditional model. So a big improvement on what we already have been doing. Now, when it comes to machine learning, it's really important that you have experts involved in the process. Otherwise, the results, you can't interpret the results. And just as an example of where machine learning got it wrong. So on the left there, a machine learning model classified that animal as a wolf. But in fact, most of us in the audience today can see that is a husky. And the reason why it was interpreted as a wolf is explained on the right, that all the other pictures of wolves being fed into the machine learning algorithm had snow in the background. So when it came to interpret a thing that looked like a dog with snow, it said wolf, but it's a husky. Another example of interpretability and the concept of AI image generation is becoming more and more popular. So someone typed into the DALL-E 2 algorithm, please generate an image of a salmon swimming down a river. And we can all see this looks a little bit strange. Maybe to a bear, this is what it would look like, but for us, this is very strange. And again, explains you need someone at the other end to interpret the result. And again, this is because most of the pictures of salmon being fed into the machine learning model is the cooked, delicious form that we see on the screen and not the actual fish form. We're also using artificial intelligence now in our well planning processes. And before I talk about that example, I wanted to show this really pretty cool picture on the screen here. So this is the troll field overlaying on an area around Bergen. And in total, the troll field covers 770 square kilometers of area. That's about Bergen and Stavanger municipalities combined. And last week, or maybe the week before, there was a world record broken in troll, the longest ever well drilled, 10,200 meters. That's 8 kilometers down, 8,000 meters down, and 2,000 meters horizontal. And someone told me that's the equivalent of drilling a tooth from 5 stories high, or feeding a straw from the tallest building in Norway down to a Coke bottle on the pavement, and then steering the straw along the pavement. So this is impressive technology. And we've doubled the estimated oil recovery from troll since the PDO. This is only possible because of technology development, implementation, both from us and our suppliers that has made this happen. And as you can see, this looks like spaghetti now. So when we drill, we're typically only 1-2 meters away from existing wells. Sometimes we even intersect with wells. So actually finding targets that make sense is getting more and more challenging. That's why we have a technology called artificial intelligence for maturation, or AIM for short. So this uses gaming technology to provide all possible trajectories to help us to see how to get from A to B. And this means that a drilling engineer doesn't need to manually try and find a trajectory themselves. They can pick off from a list of already derived trajectories. So we can make decisions in a much more intelligent way. And it also improves the competence of our engineers. It's almost like how chess computing has actually improved the game of chess, because people can see all of these new moves and it boosts their creativity. So the key to any artificial intelligence and machine learning is data. So this, Tao, is a quote from you. The well-maintained database is the foundation for our success. Data management is critical for high-quality data analytics. And we have been a data-led company since the start. And this is a historical piece of data that you see behind me. This was the first data that led to the first oil discovery on the NCS in 1967. Not the Ekofisk field, like many people believe, but the Boulder field. This seismic line and subsequent wellbore, 25-11-1, showed that the NCS had all the properties needed to be an attractive petroleum province. Back then, way before my time, these types of data were interpreted with crayons, well logs were interpreted on gym floors and corridors, development concepts were sketched by hand. And even though our methodologies have changed, what remains solid is that data are the foundation to our insights. Except now we do have modern methodologies, workflows, applications to analyze the data in a much more advanced way. So what you see on my left there is the Reservoir Experience platform. This you can access in the web browser in Google Chrome, type in rep.equinor.com, and you can access a lot of data, well data, completions data, drilling and well data, geomodels, seismic data, all in one place. Whereas before you might have to stitch together these data in PowerPoint slides. And then the other example is Bravos. This is a simple web app, but I'm showing this because this is work that I used to do every day. It would take me 1 day to analyze one well. And now you have thousands of wells just automatically available at the click of a button. And I could have shown many other examples, but the last one I want to show is Rock and Lock. And So just to set some context here, I think I need to turn down the volume of this because it's we don't need volume. So we have a tool called Rock and Log, and it's almost like a virtual data room where you can analyze core data and fin sections. So imagine I'm in Stavanger, we've got someone in Houston and someone in Rio. They can wear virtual reality glasses and actually be in the same room to analyze core data and fin sections. And this was particularly important during the pandemic when, of course, we couldn't physically meet up in person and actually do these in person. But even now, it's really, really useful for analyzing because sometimes core sections very difficult to set it up. You need to meet in one place and it takes time. But of course, we're not ruling out traditional ways of doing things. And it really takes subsurface personnel who are willing to get up close and personal to assess the validity of data. This is still essential for what we do today. Two other examples of the value of data, and none come bigger than Johan Sverdrup. So the third well on the NCS was drilled in close proximity to where the Johan Sverdrup field now exists. At the time, the well was classified as dry, but in 2006, a team re-examined the well report, and it showed that the area did have all the properties needed for a huge oil field. Of course, that wasn't the only reason for success, but it was a trigger and highlights the example of old unstructured data, reanalyzing it. And then the other example, one of our biggest discoveries 2 years ago, Blusto, and we used a methodology that's never been used in exploration before. 4D seismic data we used to de-risk the opportunity, secure the acreage, and contributed to the drill decision. And this has millions of US dollars of value creation to us and to society, of course. We're not just using data in new ways to help with oil and gas, though. And this is an example from the renewable space. And wind turbines have thousands of sensors on them, and we upload some of the data to the cloud now. For example, the wind direction, the wind speed, the turbine position, the equipment used, and we can analyze all this data to help us understand energy output and reduce wear and tear. And for that, we can boost energy from wind turbines, we can reduce the need for costly maintenance, and we can keep the turbines alive longer than expected. We're using data analytics also to help us with safety performance. So in this case, we can learn from past incidents to help us with future operations. So if you're an engineer offshore and you're replacing a valve on a flare system, you can now tap into this database all other times when people have done that routine, and you can see all the other incidents that might have happened when you're actually doing that operation. And you can put it in context of the production as well. You can minimize safety, you can maximize safety, and you can reduce the effects on production through this tool, which is the operational planning tool. And all of these examples I'm showing, it's great to see them all, but the key thing is people and teams. So the team behind the previous example is shown at the top here, and there's many other teams behind this. And we're setting up teams in new ways in Equinor. So what you see on the left there are 6 personas from A to F, representing multidisciplinary cross-functional teams. That's many different disciplines, and we're working across the company. So we have developers, data scientists, data engineers, data management, and discipline experts in the middle, because they keep the scientific integrity throughout. So this way of working, it's fun, it's engaging, there's a continuous learning mindset. And what's really important as well is that the teams are working in new ways. So you have something called an agile facilitator, who make sure that teams are working smart and doing the right things. So that's, for me, as I said, technology, data, and people, and ways of working. So these are 3 different ways of working that are now coming into our vocabulary in Equinor. Design thinking is about exploring the problem, understanding the needs of the users, and actually designing something that will make value. Lean is doing the right things in the right order, and agile is doing the things right. So working smarter, incremental, frequent deliveries, and being adaptive to changes. And I could have shown some internal examples of design thinking, but I want to use Starbucks as an example. Everyone likes coffee. So in the early 2000s, Starbucks wasn't doing too well as a company. In fact, you can see the share price in the background there. They were struggling. And the reason why is because more and more people were buying espresso machines and drinking coffee from home. So what Starbucks did was instigate a design thinking exercise. They interviewed hundreds, thousands of customers to understand what people want from a coffee establishment. What they found was it actually wasn't that much to do with coffee at all. People wanted to go somewhere where they had a sense of belonging, a homely atmosphere, and somewhere where they could actually work. So Starbucks used that information to redesign what it looked like in a store. For example, instead of square tables, they had round tables because there's no empty seats at a round table. And they designed their furniture with soft wood and stones and put people's names on the cups to make it more personal. And then you can see what happened to the share price in the background here. And they set the trend for other coffee establishments. So this is a way of changing companies and industries from within using these design methods. And it's also why we end up spending $5 for a cup of coffee that would probably cost $1 elsewhere. So coming to the end of the presentation here, I just want to end on a bit of a strategic note. And something I haven't mentioned today is OSDU. And just to explain a little bit about what OSDU is, because everyone has a smartphone in their pockets. I have 10 apps on my smartphone related to photos and video editing. I've got 6 apps related to health and fitness. They all serve a slightly unique purpose. But the commonality is that I can access all my photos in all the different apps, and I can exchange across the app. If I edit in one, I can pick it up in another. And all my health and fitness data is synchronized in one central place. This is an example of interoperability. And the idea about OSDU is to do the same for our industry, where standardization is at the core of everything. So on your iPhone, there's a lot of standardization in here, the formats for photos and videos, industrial health kit standards, and more. So that's what OSDU is going to attempt to do. And it should lead to more widespread innovation in our industry, because companies don't need to focus on the full technology stack. They can focus on little bits and pieces of it, and we collaborate where we have to. And we have an ambition that by 2027, at a minimum, all Norway assets will perform their subsurface work processes in the cloud with cloud-native data engineered for quality and accessibility. But of course, none of this actually matters unless it has a material effect on what's on top of this slide. We need to mature 300 million barrels of oil and gas a year, drill 100 to 150 wells, reduce well cost by 50%, CO2 emissions by 50%, and ultimately become a leading company in the energy transition. So a quote from Jeff Bezos here, and it's really important. We need to be stubborn on the vision and flexible on the details. It's about knowing where we're going, but accepting there's probably more than one way to get there. So even in the past few weeks and months, we've seen a lot of changes. Before January the 1st, I guess no one here had really heard of ChatGPT. And now that's something we hear about every single day, you know, at lunch, on the internet. It's becoming a common part of our vocabularies. So just to end this presentation, I wanted to show what ChatGPT could do. So I asked a rather niche question yesterday. Please write a poem about why digitalization is important to help Equinor deliver energy. So to end my presentation, I'm going to end with a poem. In our world, where energy is key and resources must be used wisely, Equinor seeks to innovate and lead in a mission to meet our energy needs. Digitalization is the way forward, a tool to help us work smarter, to harness the power of data and tech and reach our goals with ease and effect. From drilling to maintenance and production, digitalization streamlines each function, making operations more efficient and precise, reducing costs and carbon footprint size. Through sensors, automation, and analytics, we gain insights and make decisions quick, optimizing resources and enhancing safety in a complex industry that demands ingenuity. Equinor knows the value of innovation to secure our future and meet expectations. Thank you for listening.
Thank you very much, James, for a very thought-provoking presentation and putting digitalization in the perspective of petroleum. I still keep my set of crayons from my work in the Barents Sea in the mid-80s, but I see it can be done in a different way now. At NTVA, well, we still have time for a few questions, but from the audience, you have to speak really loud, and maybe we have to repeat the question for the recording. So, and who goes first? No one. It must have been very clear. There.
Just make a point, what you mentioned with crayons. I think people can hear me without the mic.
Yeah.
Okay, for the recording, okay. So digital is helping and it's changing and it can improve many things, but sometimes it is fine to go back to analog methods. As a geophysicist, there was nothing better than printing out a seismic line and actually drawing on the faults. That's a way of actually enhancing your own understanding. In my personal life, there's nothing like putting on a vinyl record on my record player and listening to an album from start to finish. Sometimes it's not just about going onto Spotify and listening to songs one by one. So it's you need to mix up both things.
Good. At NTVA, we promote technology. We arrange meetings like this one today. We also make books. So this is our gift for today's presenters. It's about how the digital affects humans in their daily life. So, thank you. Neste taler Oddvar Skjæveland, som Regional Manager for NORCE i regionen. Han har så mye interessant å vise oss at jeg må stoppe opptaket. Så vi tar den mens jeg...
Ja, ikke alle hører meg. Nå skal vi ikke overdramatisere det interessante i innholdet av presentasjonen, men del 2 av presentasjonen har jeg fått fra
Det tror du ikke? Da gir vi ordet til neste taler, professor Dan Sui, professor i petroleumsteknologi ved UiS.
Great. Hello, everyone. Good afternoon. So I'm very honored to be here to share my limited knowledge on artificial intelligence drilling. So the topic is about AI-powered digital drilling. How about now? Okay, great, thank you. So, yes, my name is Dan Sui. I'm a professor at Energy and Petroleum Engineering Department, University of Stavanger. So now we talk about AI. So what is AI? I think that we get a lot of answers from the two previous presentations. I would say that from my understanding, artificial intelligence is a very advanced technology. So to mimic human intelligence with the greater digital intelligence as well. So the artificial intelligence can do the self-learning, self-reasoning, self-interpreting, self-decision-making, and self-problem solving. So it covers and includes a lot of advanced technologies and subjects like data mining, deep learning, machine learning, optimization, data science, the decision making, a lot of new technologies and digital technologies. So in other words, so the artificial intelligence is kind of Superman's intelligence. So this is very exciting. So before I'm talking about artificial intelligence drilling, so I just want to share a story of my PhD study almost 20 years ago. So I remember my topic was to define a stable region. So how about now? It's very close to, yeah. How about now? Okay, so I try to, yeah, speak loudly. Yeah, so objective is to find a stable region. So theoretically, we would like to get this region as large as possible in order to reduce the computational complexity. However, if we use the traditional control approach, so it's difficult to get a very large region. So the region we got is kind of small, shown in this red ellipse. So 20 years ago, artificial intelligence, at that moment, it was not artificial intelligence, it was called the neural network. So neural network at that moment was still very promising and potential for the approximation. So then we decided to use the neural network to find this region. Yeah, so eventually we get this region. So it's quite larger, showing in this orange curve. So the size of this region is almost 20 times larger than the classical one. So the paper was published on the top journal of the control theory. So why today I am sharing this story? Because I would like to thank to AI. So the AI helps me to get my PhD degree. So this is without AI, I would not be here today. So on the contrary, on the other hand, I would say that compared with the traditional approaches, the artificial intelligence has excellent performance on the approximation, regression, and classification. However, 20 years ago, so there was no online machine learning courses, no powerful PC, and no open sources, and no advanced machine learning algorithms. I remembered it took me almost 1 year to learn the machine learning approaches, to write the code from scratch and debug code, and so on. I spent days, weeks, months running the simulation because of the limited computer power. So after 20 years, they are now the limited factors of the artificial intelligence solutions. So this is very good. Now, in recent half year, so yeah, so the rate of the AI development is exponential. So now more and more AI tools have been developed in different domains. For example, in coding, education, research, multimedia, design, almost everywhere. So I know that maybe most of you hear about the ChatGPT. Maybe some of you have already used the ChatGPT. So I think for me, ChatGPT is kind of tool to change my attitudes on the AI chat robot. So when I prepare this presentation, I also asked the ChatGPT one question: why the speed of the AI development is so fast now? So I get almost the same answer as the one in my mind. So I'm very happy because I have an AI friend to somehow agree with me. So I list some important factors which speed up the AI development here. So because of the data, so now it's almost the information age. So we can easily access and obtain the data from the different sources. And now we call it big data because it's with a very high data rate, big volume, big values. So, and also because of the increased computing power, improved machine learning, optimization algorithms, and also because the cloud computing and more investment in AI and digitalization. So in addition, I would like to see more and more companies and people would like to share their code, share their data, share their algorithms to the public as the source code. So which definitely and dramatically reduce the research and development time and effort. So here I also would like to say something about education. So then we realize there's some knowledge gap between the oil and gas industry and AI. So at university, we have our job to educate more and more students to meet these new changes and new requirements from the oil and gas company, from oil and gas industry and AI technologies. So now I'd like to say something about drilling. So the drilling with a simple sentence to explain it. We would like to make a hole following some pre-defined trajectory and eventually reach the target and get oil from the reservoir. So now it's almost the modern time of drilling. But still, most of the drilling operations have to be done manually or dependent on the operator's individual interpretations and skills. So for example, I use this figure to show the driller's situation. During the real-time operations, drillers are sitting in the driller's chair, and in front of her, there are a lot of monitors and show the data. So she has a lot of questions in her mind. For example, is that safe? Do we have any incidents, potential incidents? So can we drill faster? So is that new formation? The wellbore is stable. Shall we shut down the valve? Yeah, so a lot of questions. So for the driller, it's difficult for her to capture all the dynamic information and answer the questions in her mind and make the optimal decisions. So yeah, doing this real-time job, yeah, is very challenging. So the question is how to help the driller out of this situation. So I would say that artificial intelligence and automation are the two important potential tools to help driller regarding it. So the artificial intelligence is very powerful tools regarding the decision-making, problem solving, and reasoning. And automation is kind of successful industrial technology to operate the control systems, to reduce human in this loop. Actually, if we can combine the artificial intelligence and automation, so actually we can reduce the humans' intervention during the real-time drilling operations. In the meanwhile, we can keeping the greater digital intelligence. So actually, this is kind of ideal and perfect business model. But the question is, how should we do and where we should start? So please allow me to use self-driving cars as an example to explain or discuss the possibility of the artificial intelligence drilling implementation. So for the self-driving cars, we have some objectives. The first one is to navigate the car in order to avoid any collisions. We also need to control the car speed, not too fast or not too slow, using the cameras, using the sensors or radars. But for the self-driving car, it's quite important to deal with the very challenging and the dynamic surrounding environment, try to avoid any risks. It also needs to make the decisions as quickly as possible, as precisely as possible. So this video shows how the Tesla car, self-driving car, is tested on the road. So it can automatically detect the speed limit sign and so detect any obstacles. Try to steer the car following the correct path. So, but at that technical level, current technical level, we have to keep the driver in this loop for the emergent case. So now we compare the similarities between the self-driving car and AI drilling. So both of the systems need sensors. So especially the AI drilling need the downhole sensors to capture the downhole environment. And both of them need the machine learning algorithms or data mining algorithms to make predictions on the drilling or on the parameters and optimize the performance accordingly. And both of them put safety as the first design criteria. However, compared with self-driving car, so the drilling has more technical challenges. So the drilling has limited data in terms of data volume, data type, data velocity, data quality, and the delay. And also the drilling is deal with very complicated drilling environment, especially the downhole environment. So it's very challenging and unstable, sometimes unstable and sometimes unpredictable. So in order to avoid any drilling risks, for example, gas kick, for example, the washout, leakage, blowout, it's quite important for us to make the corresponding safety standards, safety regulations in terms of the AI drilling. So in conclusion, the implementation of the AI drilling is more challenging than designing the self-driving car. On the other hand, so the here I mentioned technical challenges. Also for the traditional drilling, we also face this most of the technical challenges. We need to use the digital tools, automation tools, or AI tools to make the traditional drilling more efficient and safer. So here I list some potential AI drilling applications. So here I list almost 8 potential applications. I would say there are more than 8. So I put these 8 applications into 5 catalogs. The first is performance monitoring. Yeah, so we can use the AI drilling to monitor the drilling behaviors, especially the downhole drilling behaviors. Especially, we use the data mining to detect the data patterns and using the signal processing to capture the data dynamics. So especially, so the AI drilling has the potential to deal with the big amount of data. So from the smart sensors, for example. So the AI drilling can be used for the safety monitoring. So we can use machine algorithms to detect the drilling incidents, valve stability. So for example, and also we can use the machine learning approaches to estimate the drilling parameters ahead of time or ahead of the bid. So for example, to predict the downhole pressure, the rate of penetration. And AI drilling can be used to optimize the drilling performance. For example, using the decision making based on the data, information, the policy, to adjust the real-time drilling parameters, to reduce the non-productive time, to reduce the drilling damage, drilling equipment damage from the vibrations, to optimize the drilling fluid design, and also optimize the drilling speed, tripping speed. And the last one is we can use the AI drilling to analyze the historic log data for the planning and the design phase. As the researchers, we know that the AI drilling is kind of the cutting edge technologies. It has a huge potential. But as the new technology, AI drilling, of course, is coming with some limitations and problems and issues. We could not always say some good words about AI drilling or AI. We also need to face and think about the limitations. Yeah. So our job is to spend more time and effort on the limitations or problems of the AI or AI drilling. These kind of limitations. So here I would like to discuss the limitations from these 5 aspects. Yeah, the data is fundamental of the artificial intelligence technology. So we started this AI drilling almost 6 years ago. So we spent a lot of time, almost 80% time on the data preparation. Especially the drilling data has a lot of issues and problems. Data with noises, data with gaps, data with errors of layers. So it's quite important for us to clean the raw data and use the clean data to develop models or develop algorithms. And also, sometimes we just get the digits, numbers, or values. There is no more explanation. And the definition of the parameters may not same if we take the data from the different companies. So this is quite important for us to have some standards on data. For example, to have the standard glossary, to use the same definition on drilling parameters. So also I would say that, so as the researcher, we need to put more effort on data itself. And the second is about the models. So the machine learning model is kind of data-driven model. So compared with the mathematical models, there is no mathematical equations. So in that case, yeah, to interpret the data model is difficult. Yeah, so it's good to find a way to have a better understanding the data-driven models. And also, yeah, we also got questions from the other researchers and the customers or yes, people mentioned that. So the data-driven model is lack of the physics. How are you going to solve this problem? Yes, I would say that, yeah, sure. For the drilling is a still traditional industry. We still need to drill a physical well. Yes, physics-based model is fundamental. But the physics-based model was developed still based on a lot of assumptions, yeah, conditions or restrictions. So there are a lot of unmeasured coefficients are involved in this physics-based model. So the data-driven model is kind of good supplementary tool for the physics-based model. For example, to use the data to estimate some parameters involved in this physics-based model. And yeah, now we talk about applications. So we know that the machine learning model or machine learning algorithms are not mature. So before we implement this kind of machine learning models, we also need to do a lot of work on the model validation, model testing, especially on the full-scale rig for the proof of the concept. But this kind of work is very risky and costly. So from the safety perspective, we also need to have safety standards and regulations. We also need to think about how to integrate the AI solutions into the existing drilling systems. Also, from the education perspective, we need people with the multidisciplinary knowledge. So it's quite important for us to educate more people who know both AI and drilling. So now I also want to say some words about what we have done and what we are doing at University of Stavanger. So now we are running the project called the Intelligent Drilling. So we start from the data and doing a lot of data management, visualize data, process data, and share data. And we extract useful information and important information from the data. So this information includes data patterns, data dynamics, try to better interpret the data. And then we develop models based on the data and the information. It includes the physics-based models as well as data-based model or hybrid model. And this model and knowledge will be used for the drilling optimization, for the detection, and also drilling automation. So here I would like to use several examples to explain our work. So here I show some examples about the drilling data issues. So here it's quite normal that the data with gaps. So sometimes a small gap, sometimes bigger gaps. And now it's also quite normal that the data is with noises. And so this case is showing that the hook load data is with errors. So the sensors got failure and could not give the right values of the measurements. And what if we have the measurements from the different sensors? Which value should we trust? So to answer these questions, we developed this automated data pre-processing algorithm. So it has the 3 steps. So this algorithm can automatically detect the drilling data issues and measure the data issues. Then the second step is by using the different data processing ways to improve the data quality regarding the gap fillings, regarding the noise removal, outlier removal, and also the error correction. And last step is about process data assessment. Because for someone just want to trust the raw data because they think the raw data will not be removed from some useful information. But it's quite important. But let us show, even after some data processing approaches, we still can use the process data with the valuable information. And next example I would like to show is about the AI drilling software we developed at University of Stavanger. So we have the limited resources, right? So this web application is not fancy as the one developed at Equinor, but this web application or the software was developed based on what we designed, basically what we developed from our scientific papers. The methodology is not so, is also, I would say that it's quite advanced, but the software may not so advanced. So this web application is designed for the education and research perspective. So it can be used for the data sharing, data visualization, data analysis, data processing, and based on the data to develop the fit for purpose models for the different applications, like radar penetration prediction, and also the inclination prediction, and so on. So this is a very good opportunity for our students and research. They are not from AI, but they can use this web application to learn and practice AI technologies. So from 2020, we also developed this in-house drilling simulator for directional drilling. So this simulator includes many subjects. So include the physics-based model, like RSS model, steering model, and also have this AI models to predict the bid position, and also have the AI agent to recommend the set points of the drilling parameters in order to avoid any risks and for the safety perspective during the real time. And then we also have the trajectory control agent, which can base on the real-time drilling parameter set point and the bid position to steer the bid following the right place. And also, our students also built this small-scale physical rig. Yeah, so this is a kind of amazing work because there is no opponent. The student make this rig from the scratch. So even customize the small drilling component. And this rig is very functional. It can run the different drilling operations, tripping, drilling, a lot of things. And it's also a good experimental setup to test the automated drilling and AI drilling. For example, formation classification, for the detection, data management, and drilling optimizations. So here I would like to show a video. So this drilling rig was run without in the autonomous mode, without human intervention. So it can drill and also detect the potential problems. If it detects heavy vibrations, then the drilling operations just stopped. So this operation was given actually by the AI agent. So last thing I would like to say is about education. So from 2018, we were running this student project called Geobotics. Each year, we got many students with the different disciplinaries or backgrounds from the data science, computer science, mechanical engineering, besides the petroleum engineering. The students were working together under the AI drilling, autonomous drilling project topic, and the students working together to learn each other. So this is a very opportunity situation for the student to learn the multidisciplinary subjects. And also, the student using this opportunity to participate in the annual international competition called the Geobotics, organized by the SPE. So in 2021 and 2022, we got the first place from the international competition for the digital rig simulator development. And the last 5 years, we formulate a lot of master, bachelor thesis topics within AI, within automation. And also, yes, our team involved bachelor students, master students. We work together. We also published a lot of scientific papers on the international journal and in the international conference. So the last slide, I would say that our objective is light drilling. With the help of AI automation, be easy, be efficient, and be safe. Thank you for your attention.
Yes, thank you, Dan, for a nice presentation about AI in drilling.
Thank you.
It was nice to see the Drillbotics team again. The first time I met you, it was during the national competition of Drillbotics some years ago.
Yeah,
Before-
2016.
Before you entered the international. I was one of the judges.
Yes, I remembered. Yeah.
So that's why I asked you to come here today, in fact. Big surprise. I have a gift for you also.
Thank you very much. Yeah, I really appreciate. Yeah.
Okay. We also have time for questions from the audience. Yes.
Yeah.
The question and
Yes. Yeah. Yes. Okay. Yeah. So then the AI covers a lot of subjects like data science, computer science, the optimization algorithms, and the data management, a lot of things. So I would say that we need people, yes, who can use AI, who can develop and implement AI solutions. So this is quite important. So we have the petroleum students. So they are, yeah, learn some things from the bachelor or master studies. Is almost focused on the traditional drilling systems and old school knowledge. I would say that, of course, they change, yeah, our study program a lot. But still, when I teaching the automation in my class, I would say that especially the international students, they have no idea about automation, data processing, and also, yeah, data management on this kind of things. And yes, in the future, yeah, you will definitely, yeah, the petroleum engineers and will use the AI, yeah, or the digital tools. They need to know what kind of the series or the knowledge behind these digital tools. I think this is quite important. Also, on the contrary, regarding the data scientists, they don't have such domain knowledge regarding the drilling. So of course, yeah, so they can learn, but I would say that they may not so interested in this kind of physical systems. So I would say that our objective is also offer the students a kind of the knowledge in different disciplines, like data science, computer science, electrical engineering, cybernetics, or information technologies, yeah, like this. Thank you. Yeah.
another round of applause. We are now coming to the interview of today's Ærespris winner with Teknisk Ukeblad. So they will have some time to rig their recording setup.
Det er ikke et vanlig intervju, men det er en intens podcastinnspilling som vi begynner å nærme oss 500 innspillinger nå. Så vi har gått på med det her en stund. Skal vi se. Ja, du er du? Ja, ferdig. Godt å ha litt avfart. Stått der om plassen, kanskje. Ja, men det går bra. Sånn. Nei, jeg har sjekket lyd. Så sitter jeg bare se om vi er den.
emit sounds? Okay. Yeah. I think we have you here. And Jan?
Yeah.
You are loud and clear as always. Okay. Da vi klar. Ja, uka her. Ja. For det her jo aktuelt, veldig aktuelt, så vi må få det utenfor det vanlige podcast-regimet.
Ja, vi har akkurat kommet I går, og I dag har vi laget podcast.
Etc.
Men så det å si da, at
For veldig lenge siden, ja, som dere ser, dessverre. Ja, vi fikk valget mellom første og andre anledning. Vil du gå på gruvedrift eller oljeteknologi? Og da bommer jeg. Jeg prøvde å bytte etter ferien, men nei, det var ikke snakk om. Plassene var fordelt.
Derfor står vi her sammen.
Og barna mine hadde snakket så her. Ja.
Ja. Men nå har vi hatt en liten plan på forhånd. Jeg tenkte at vi åpner podcasten her.
Men du ville heller at vi kjører den på engelsk?
Ja da, det
gjør vi. Så du får si at når vi klar, Jan?
Ja.
Da kjører vi starten på norsk, og så går vi over engelsk. Vi kjører.
Du hører på Teknisk sett, en podcast fra mitt navn Tao Yang.
Hei, Jan.
Richard, vi
Det vi.
Der ærespris involvert.
Ja.
Det et prosess.
Teknisk naturvitenskap.
Ja.
Jeg I ferd med å bli.
Ja,
der ser du.
Blir det enda mer effektivt. Vi skal snakke litt hvor prisvinner har dokumentert en lang gjennom innsats over mange år den vanlige basert på en reservoardatabase kan maskinlæring gjennomføres for å muliggjøre Teknologien blitt verifisert fra mer enn 100 brønner fra En nøyaktig identifikasjon av reservoarprodukt og møter
Det får vi komme tilbake til.
Det kan vi komme tilbake til, og da begynner vi over til vi har Congratulations. Thank you for that. You understood what I was reading? Oh yeah, I do. But now you have to explain to us better now that you know, just as of today, we have a say that we take review the and we everything that we're speaking today, talking about we're talking about this type of it's mainly use data we accumulate especially this technology very much the data we use history reason that task they have is to find oil. Not actually the most why the data sort of like a big read all this that's why we're inside of forward more talking about the foundation work process and
So to be clear, for the whole period of the oil industry in Norway, geologists have been sitting in front of paper and screens looking at the seismic data as a tiny little group to look for oil. Yes.
Seismic is a very important data.
Yeah. And they were not available for your use.
You know, yes or no, and so you know, all these production decisions are happening.
Yes.
And or you know, if we can other means to improve the accuracy what's from the full test. That's a lot of more value.
So you had to make this available for your methods.
Exactly.
Yeah, which was quite a job, I suppose.
Yeah. So luckily, now we have a organization already had years
Mhm.
before, and applied it to geoscience and engineering. And especially with the digital that we were really that makes it easier. Then I moved down. This is exactly the challenge. So we can have this stuff. These are all usually are very when the targets become smaller and smaller, and you're limited by the 40 destination resolution. So your target is less than that, and so it's very. That's why when we use this the data already in the industry for many decades, now we can borrow that data, we can improve the accuracy to the meter level about where is gas, where is oil, then we can make a very precise prediction. But one thing I talked about is the flow for the oil. Maybe I'm not the best person to talk about this, and actually, the work started in 2005. The old oil company, this is really cheap of the banks. Look at all the banks today. Stock market machine. Not the people trading the share. So it's a big achievement in the bank sector. That's really make the oil sector start to think when the oil price is so low, how we can late. But luckily that with 5-6 years time and the learning curve, I believe it's late. After that, you know how things.
And of course, with all these data you now have digitized, you can use machine learning, AI, everything to optimize drilling.
Exactly.
Yeah.
And also there's a lot of better tools now. I had a chat before talking about how the report looks like. And nowadays there's a lot of smart ways. We build our data. We use that work in today's situation can be done from it. So there is a big improvement. So data is widely available, like data is widely available. Of course, there is a big job, like all the machine learning projects have to build the data. Naturally, people have noises. Work on the data. Typically, people say you spend more time on the data than the model.
Yeah.
So machine learning takes less time than bring us down to yeah, I think the three, the technology basically use which is a gas on a rig, like so we thought of fingerprint from the gas. Already there in place. This use that technology, you can tell where the gas oil. So this information is very important for, pushing well, you drill a hole, you want to know where the gas is. That's why our technology main advantage is that when you don't have all this information, you have all you need to make a lot of decisions. The resolution of the data you have. This is where that the data part and you do the color filtering.
Did they sample the mud data? Did they save the mud data from the beginning of the oil age as well?
Yes, and so we did some work for all the data are.
So you knew when methane came up and when it approached oil density, etc.
Yeah. So depends on what type of mud gas. In the old days, like 7 days, 8 days, we have a few components, and they have probably components together, and we can tell the type. We don't tell the problem. We can tell this is oil, this is gas. But nowadays, from 90, they have more advanced. You have a 7 components from D1 all the way to D5, and then you can actually tell the problem. That makes the decision depending on what you have. Work on the legacy well, old well from many years back. You have the most modern gas data, we can actually give you a lot more based on.
So the C number, what you're talking about, is the length of the hydrocarbon molecule coming up.
Yeah, because the gas is very much from D1 to D5, D1 is methane, and D5 is
yeah.
So this is very much the gas. One thing that I think is very fascinating. Because our machine learning physics involved. Yes, they're physics because of the lagging time caused by. So you naturally will have 1 to 2 hours lagging, and depending how use the data interpretation like finish off the feeding, and you don't care about 1 hour. But while we're speaking now, we have a level in Lisbon, so that really requires real time. And you have 1 hour lagging time, you might face some difficulties. Overshoot. Exactly. So, but kind of feeling people will naturally down a little bit. So, well, this actually cool. But I have thought this is helping for the
And it drips down over all of us.
But the PSA, yeah, plug and web. Yeah, this is our next big target because the PSA, Norwegian job, about 30 business, the spending about 800 billion. Big money we're talking about. Although this is paid by the government, most of it, 78% paid by the government. We're like more 500 we can make the stuff. Make one for yes, how to do it is our next step. We really try to use this technology to actually burden some of the barriers and unnecessary data. So when we take that small piece, so you're talking about the last question, we're out of time. Well, congratulations, senior specialist Dr. Tao Yang, Equinor. Congratulations. Thank you for speaking to us.
Thank you. And you're not going to Las Vegas to spend your prize money, are you?
There is no prize money, by the way. Okay, well, yeah.
Det neste som foregår, det en uttalelse på Lerholm i regi av Stavanger kommune. Helt time å forflytte oss til Lerholm.